Let's talk about energy level diagrams. So let's look at the periodic table to review the maximum number of electrons in each orbital, s, p, and d. We have not covered the f orbital yet. So as you can see, the s orbital can have a maximum number of 2 electrons. And how do we know that? Well, the s block consists of these 2 columns. So that's where you get the 2 electrons. It represents the number of columns, the 2 electrons. So moving on, let's move on to the p orbital. That can have a maximum number of 6 electrons. And how do we know this? Well, in the p block, we have 6 columns, which represents the 6 electrons in the p block. Now let's move on to the d orbital, which can have a maximum number of 10 electrons. And here's a d block, and there's 10 columns in the d block. So therefore, there's your 10 electrons. Not all of the elements that I discuss will use all these orbitals, but I have pre-drawn them since I will talk about several elements. Now, what am I saying about pre-drawn them? Well, if you look at here they are. I've pre-drawn them. Now, this is what I'm going to use for all these elements listed here, but that doesn't mean that each element uses all these orbitals. I'll circle the answer as to what the right orbital representation is for each element, so you know what to use. Now, so how do you know how to draw the diagram? We use the order we used in the order filling chart for electron configurations. Now, which one was that, you may ask? Well, I did a video on this. So basically, the way I put these in order was, and once again, you're not going to use them for all the elements, but this is what I'm going to use for this video. So you put the 1s first, you go in the direction of the arrow, then the 2s, then the 2p, then the 3s, then the 3p, then the 4s, and we're going to stop at 3d for purposes of this video. So going back, and here they are, the 1s, 2s, 2p, 3s, 3p, 4s, 3d. Now you know what order to put them in. So that being said, let's start off with hydrogen, all right? So here's hydrogen, and its electron configuration is 1s1. So what do you do here? How are we going to build this energy level diagram for hydrogen? Well, what you need to do is, since hydrogen is that configuration of 1s1, you need to draw 1 electron in the 1s orbital. And this is the subshell right here, this box. So how are we going to represent this? Well, we know that it's 1 electron, represented by that superscript. So let's go over here and we're going to draw just 1 electron. And how do you draw that 1 electron? It's represented by an upward pointing half arrow. So that being said, let me see how we can best do this. So there's the half arrow. Well, you should fit it in the box. Let's see if we can do this right. So you have to fit this in this box like that. That's one of the arrows. You could do a better job of it fitting it in the box, but you get what I'm saying. Okay, so that's hydrogen. So this is your answer right here for hydrogen. Just the 1s orbital. That's it. That's all you need. So moving along here. I'm going to leave this already written because you might need it for the next one, which you will need it. So helium, the electron configuration for helium is 1s2. So you need to draw in 2 electrons. Now the superscript is 2, so that's your 2 electrons. So in this same box, because we're still in the 1s orbital, you're going to represent it with that upward pointing arrow, that's a half arrow. And then you need to put in another electron that's represented by another half arrow. All right, so let's do this. My drawing's not the best, but you had to just put 2 electrons in there to represent helium. So we'll leave that drawn, but this is helium right here. That's helium, all right? Now moving right along here. So after helium, we're moving on to lithium. The electron configuration for lithium is 1s2, 2s1. Now, we know we have 2 electrons in the 1s orbital. We already have those drawn, so no need to do that again. Then lithium is going to be 2s1, and it's 1 electron represented by the superscript. So once again, you're going to represent that 1 electron by an upward pointing half arrow. So here we go again. Let's put in that upward half arrow, but just make sure you fit it in the box. I'm just trying to show you how to do this. So that's lithium right there. This is lithium right here. That's your representation right there. Now, moving right along here, let's move on to beryllium. Beryllium's electron configuration is 1s2, 2s2. Well, we already have the 1s2. Now 2s2, we had to draw in 1 more electron here. Well, let me try and fit that in there. Your guys's will probably look better than mine. But anyways, that's beryllium right here. That's your representation, all right? Now, moving right along here. Let's move on to nitrogen. Electron configuration is 1s2, 2s2, 2p3. Well, we already have the 1s2. We already have the 2s2. Now we're going to go on to 2p3. Now, how are we going to do this? Well, there's a rule called Hund's rule. And Hund's rule says that you're supposed to put in, now there's 3 subshells to the 2p block, all right? 1, 2, and 3. It's these 3 boxes. Now, Hund's rule says you need to put in the electrons first and single. You put the single electron in one box, then another box, and another box. And after you do that, you pair them up. But that's not going to be the case here because we only have 3 electrons. I'll show you with the next element how that works. But first, you put them in as single electrons in each box. So that being said, we're going to put in our upward pointing half arrows. Here's 1, here's 2, and here's 3. Now, once again, you want to fit them in the box as best you can. I'm just trying to show you how to do this. Your representation will probably be better than mine. But anyways, there's your energy level diagram for nitrogen. Of course, you'll always know if you have the right number of electrons because you add the superscripts in each case. I'm not going to go through all that. I've talked about in other videos, but like just in this case, you have the 2 plus a 2 is a 4 plus a 3 is a 7. And you look at your boxes, you have 2 electrons in the first one, which is a 1s, then 2 electrons in the 2s, that's 4, and 3 electrons in the 2p orbital, all right? So that being said, let's move on. Let's move on to neon. Now neon is, here you have your 1s2, here you have your 2s2, now you need 2p6. Well, Hund's rule says, since you have 6 electrons, you already have 1, 2, 3, which we drew from the prior one, the upward pointing arrows. Now Hund's rule says you put them in single in each subshell, and then you pair them up, all right? So here we go. So we're going to put another electron here. Let me try and fit that a little bit better. There's 1. There's 2. There's 3. That's the best representation I can give you. I mean, your picture's going to look a lot better than mine. But in any event, so this is right here. This is neon. All of this. That's your energy level diagram for neon. And if you're looking at this, it's like you're going up steps. It's like a staircase, steps in the staircase. That's what an energy level diagram is. Now, moving right along here, we have silicon, which is, okay, here's the 1s2. There's the 2 electrons we drew in there. Then the 2s2, 2 electrons there. And 2p6, there they are. Then we have 3s2. Well, 3s2 is really easy. It's going to be just like the 1s and the 2s. You're going to draw them the same. So you have 3s2. So it's 1. Let's do that again. I can't even do my half arrows here. But here's the 1. And here's the 2. All right. Just make sure you draw them within the box. I'm just trying to show you how to get through this. Now, 3p2 is the last part of that. Once again, Hund's rule. You're just putting in single electrons in each subshell. And this one has 3 subshells, just like 2p. So we said 3p2. So you're going to put an upward pointing arrow here, half arrow. Okay, here's the half arrow. Okay, I'm trying my best here, you guys. Technical difficulties, please stand by. So I'm just trying to get you going on these energy level diagrams. 1, and then 2. And of course, it should be within the box. You're trying to get it within the box as best you can. So that's silicon right there. All of this is silicon. That's how you draw the energy level diagram for that one. Now, that being said, let's move on to chlorine. Now, chlorine. Yeah, the 1s2, the 2s2, the 2p6, the 3s2. You need 3p5. Well, let's complete this. Here's 1, 2. Let's move in another electron here. 3. And then 4. Now you start pairing them up. And 5. So you can draw it better. It's getting there. So that's chlorine right here. Here's chlorine. All right. Now moving right along here. Moving right along. We're on the last one. This is a home stretch right here, zinc. So you have the 1s2, you have the 2s2, you have the 2p6, you have the 3s2, you have the 3p6, then 4s2 is going to look like your 1s, 2s, and 3s. So here's 1 and 2. There's that one. Now, what's left? 4s2, now 3d10. You're going to fill this whole baby up here. You're going to fill up the 3d10. So you're going to put first single electrons, but it doesn't really matter because you're going to fill up the 5 subshells. This is 5 subshells. 1, 2, 3, 4, 5 boxes. It's hard to draw these, especially when you're trying to do it online here. It doesn't matter on this particular one. So there's your 10 electrons. I mean, I try to do as best I can, but really what you're supposed to do is each box should look like this. Here's your box. And here you have 1 electron and then the other. That's the way it should look in each box. So just want you to make sure you know what I'm trying to do there. So that's how you complete energy level diagrams. And that's that in a nutshell. I mean, it's like a staircase. You're going up a staircase. So that concludes our lesson on energy level diagrams.